Example 7.4.4. In this one, we're going to calculate the expected return and beta of a portfolio. And again, if you have not watched the video, two videos before this on diversification, beta, the capital asset pricing model, and an earlier example, all that's in the title. I'd go back and watch that one because it gives a lot of background about what beta is, the risk that it measures, and why we care about it in this context, and why it's different than standard deviation. And that background information will be good to have going into this problem. It'll make a lot more sense. Or if you've read the chapter and digested that information, you've got all that as well. There's nothing in the video that's not in the chapter. Okay, let's set this one up. So suppose you have a portfolio made up of 30% stock A, so that means 30% of your money is invested in stock A, 20% stock B, and 50% stock C. Notice that these sum to 100, so we've got 30 plus 20, which is 50, plus 50 in stock C. So this is 100% of our money spread across three stocks, where 30% is in stock A, 20% is in stock B, and 50% is in stock C. Stock A has an expected return of 6% and a beta of 1. Stock B has an expected return of 8% and a beta of 1.2. And stock C has an expected return of 4% and a beta of 0.9. What is the expected return and beta of your portfolio? On the first video for this chapter, when we looked at the first example and went through example 7.2.1, 7.2.2, and then we really looked at the data that was in table 7.1 where we had Initech and Edison Power. And then the next video where we looked at table 7.2 where we added Fixitech, and we looked at what happened with the expected returns of the portfolios and the standard deviations of the portfolios. And what we found was that the expected return on the portfolios, or the average return in that case on the portfolios, was just a weighted average of the returns on the individual assets. There was no change that happened because we combined them in portfolios other than what we would expect. We're just going to get an average of what's in them. Something weird happened when we looked at the standard deviation, though. When we had stocks that tended to not move in the same direction at the same time, and especially moved in opposite directions, we reduced an awful lot of risk. Our portfolio of assets maintained the return that we expected, but we had a lot less risk. And actually calculating the standard deviation of a portfolio is a fairly complex equation that is outside the scope of this particular class. But it's a pretty ugly equation. We can do it, but for every asset you add to the portfolio and you get past 2 or 3, it starts to be a very, very long calculation in order to be able to do that. But when we instead measure risk with beta, which is the individual asset's exposure to the risk of a well-diversified portfolio, something really cool happens. In this case, the risk of the portfolio, which now we're measuring by beta, becomes just a weighted average of the individual betas. There's no weird diversification thing happening here because we've already accounted for it by measuring risk with beta. So what we can do now is calculate the portfolio's expected return as a weighted average and the portfolio's beta or risk as a weighted average. Right? And a weighted average is where we just take the weight of the particular asset. In this case, let's say we're calculating the expected return. We'll take the weight in asset 1 or stock A in this case. We'll multiply that by the expected return of asset 1 or stock A in this case. We'll add to that the weight in the second asset, which is stock B in this case, times the expected return of the second asset, just stock B in this case. And we'll just do that for however many assets we have. In this case, we have 3. We've got 30% in stock A, and stock A has an expected return of 8%. So we'll take our 30% weight here, because 30% of our money is in stock A, has an expected return of, 6%. I was looking at stock B. Stock A has an expected return of 6%. So we'll take the 30% weight times the 6% expected return. For stock B, we've got the 20% weight times the 8% expected return. And then for stock C, we've got 50% of our money tied up in that, and we're expecting a return of 4%. So we do the multiplication first, and then we do the addition. We follow the rules of the order of operations there, and we figure out that our portfolio has an expected return of 5.4%. Now, there's a good reality check we can use here when we're calculating weighted averages. This is just an average of the individual assets, and so the number you come up with should be somewhere in between your lowest observation that you plugged in to the expected return equation it should be somewhere between the lowest observation and the highest observation. It can't be lower or higher than the values that you put into it. It's going to be an average of what's inside. And in this case, our highest return was 8%, our lowest was 4%, and sure enough, 5.4% is right in between that. And we can actually know even a little bit more about it before we even do the calculation. It should be, because this is a weighted average, if there's more weight on any one particular asset, then the return that we come back with should be closer to the return on that asset, because most of our money is tied up in it, so most of our money is going to have a 4% return in this case, right? Or we expect it to anyway. And sure enough, that 5.4% is a lot closer to 4, or is very close to 4. 6% is not that far off either, so it's going to kind of be in between those two. And only 20% is in that 0.08 asset or 8% return asset, so it's not going to add a whole lot to it for us. So before we even do the calculation, we can know an awful lot just based on the weights and the observations that we're plugging in, and we can do kind of a reality check when we get the answer back. Calculating a weighted average for beta is exactly the same thing. We take the weight times the beta, and then we just add those together for every asset that we have. In this case, we've just got 3. 30% of our money is in stock A that has a beta of 1. 20% of our money is in stock B that has a beta of 1.2. And 50% is in stock C that has a beta of 0.9. So we do the multiplication first, and then we do the addition, and we find that the beta of the portfolio is 0.99, or very, very close to 1. So now we have a much easier way to calculate both to calculate the risk. We're still calculating return in the same way that we did before. We have a much easier way to calculate the risk of the portfolio instead of the big ugly equation it would take to calculate the standard deviation or expected standard deviation of the portfolio.